This is section 4.7, more equations and inequalities. And we start out with just reminding ourselves about solving a rational equation. So let's look at this one and look at this example. The example is 6 over x squared minus 5 over x equals 1. Because we have rational expressions here, we need to find an LCD to get rid of them. X squared is the biggest thing that both of these things will go into. All right, and so x squared will be our LCD. So then we multiply every piece by x squared over 1, and then canceling out the things that do cancel out. X goes into x squared x times. The 1's cancel out, so we're left with x squared there. So when we finish, we should have no fractional parts. We have 6 minus 5x equals x squared. Let's go ahead and we would get these pieces over here to the other side so that you would have a plus 5x and a minus 6 here. That's a quadratic equation that we could factor, and we get x equals negative 6, x equals 1. We do want to make sure that if we put either of those in the bottom, that it's not a problem. And in this case, it definitely isn't. So that would be our solutions. Now, when we look at polynomial inequalities, let's look at what's in this concept chart. So here's the difference. If we're solving negative x to the fourth plus 5x squared plus 4 equals 0, and we put it in the graph, and we get our shape, it is these 4 points that are the x-intercepts that are our solutions. But if we're using that same expression but saying where is it greater than 0, well, you should notice that greater than 0 is this piece and this piece, and our answer is about the x, so it's between negative 2 and negative 1 and between 1 and 2. And here's the way we will most likely see the solution written, interval notation. If we were solving that same expression for less than 0, then that's going to be the pieces that are below, because 0 is right here. This is where y is equal to 0. So anything less than that would be down here. All right, so we can see it's from negative infinity up to negative 3. I guess that's negative 2, sorry. And then between negative 1 and 1, and then from 2 to positive infinity. So here it is written on just an inequality number line. Here it is in the interval notation. So that's what we're going to be doing, and the way we're going to do them is use our calculator to get us a graph, sketch it, and then determine the right solution. So those we've kind of looked at before, especially in the calculator unit. But rational inequalities, we haven't done before. And so there are some steps that we're going to follow. Find the solutions of the top and the bottom. Draw a number line and use those solutions to separate. Define the intervals. Pick a test value in each interval and determine the sign if you plugged that in, and then 5, write the solution. So you don't have to memorize those steps, but you have to know how to use them. So let's go ahead and do this example problem so that you see what we're doing. All right, so here is our original, get rid of this. Here is our original problem. 2 minus x over 2x is greater than 0. So we have a rational expression, inequality. Solve the top, set it equal to 0. That's this part. So we'll solve the top, and we'll solve the bottom. So we got 2 and 0. Next step was to draw a number line and separate it with those solutions that we found. We do them in order like on a number line. So x equals 0 goes there, x equals 2 goes there. We define the intervals. always have negative infinity on the left and positive infinity on the right. So this interval is from here to here. This interval is from here to here. And this interval is from here to here. So we defined those. Then we pick a test value that falls in those intervals. And you want to pick something that's easy for you to plug in. I picked -1, I picked 1 in between 0 and 2, and I picked 3. You could easily pick 535 in this interval, but you got to plug it in. So you want to make it as simple as you can. So remember that here is our original 2 minus x over 2x. If we plug -1 in, we have 2 minus a -1 over 2 times -1. And so that becomes 3 over -2. The sign of that number is negative, so I put the negative there. If we were going to plug in 1, we have 2 minus 1 over 2 times 1, and that's 1/2. The sign of that is positive. And you do the same thing for plugging in 3. You get a negative. We are looking for the solution for where this is greater than 0. Greater than 0 is positive. The only positive interval is 0, 2. So our solution is the interval between 0 and 2. Anything in there gets us a true statement in our inequality. So now I think we're ready to work on some problems and do some practice. All right, number 1, solve this symbolically. So it's very much like our problem we did in the lecture notes, and we'll notice that we have an x and an x squared. Our LCD will be the x squared. So let's write this down here. 1 minus, and I'm giving myself some room, plus 30 over x squared equals 0. And I want to multiply every piece by my LCD. Every piece all the way. So then we have an x goes into that and leaves an x here. We have the x squareds cancel out there, and then this is simply going to stay at 0. So let's see what we have left. We have x squared minus 11x plus 30 equals 0. That's a quadratic that we should see if it factors. Factors of 30 could be 2 and 15, 10 and 3, 6 and 5. 6 and 5 seems to lend itself to 11. How about x minus 6, x minus 5? And so that would give me x equals 6, x equals 5. In your box, you would put 5, 6, not parentheses, just the solutions. All right, find all the real solutions of the following. Now on this one, think about this. If we took this whole thing and multiplied both sides by x plus 2, okay, what happens? Gone. And over here, that times 0 is just 0. So we're left with x minus 1 equals 0. So x equals 1. All right, now, which one of these are we going to plug in? Extraneous solutions, what that means is that you come up with a solution here that if you plug it back in, it doesn't work. We don't have any of those. We do have a real solution, so it looks like we're going to choose this and plug in 1 right there. All right, let's look at number 3. Same idea. What is our LCD here? The LCD is x squared. So we're going to multiply each piece by that. So we've got x squared here, we've got x squared here, and we've got x squared here. We're left with an x here. So what do we have left? We have x minus 5 equals 4x squared. Okay. Now, let's bring everything to the other side. So we have 4x squared minus x plus 5 equals 0. Now, I don't think that looks like it's going to factor, and here is where our discriminant can come in handy and let us know if this is even going to have any real roots. Remember that the discriminant is b squared minus 4ac. And so in this case, that would be negative 1 squared minus 4 times 4 times 5. That would be 1 minus 80, which is negative 79. Remember that if we get a negative value, it tells us that we have imaginary roots. We don't have any real roots. All right, now let's look at our choices here. Can't be this. We don't have any real solutions, and we don't have an extraneous solution. We just have this. So that's a time when you think it's not going to factor, you might try to just do the discriminant, and if you get a negative number, you know you're not going to have any real solutions. All right. On this one, same idea as the one before the last question. If we multiply both sides by x squared plus 5, we end up with x cubed minus 16x equals 0. All right, so that's what we're going to work with. We're going to solve that. All right, if we solve that equation, what can we factor out here? We can take out x, and we're left with x squared minus 16 equals 0. This factors to the difference of two squares. So we've got x times x minus 4 times x plus 4 equals 0. All right. So we have x equals 0, x equals 4, x equals negative 4. Now, in our original thing, none of those are a problem in the bottom because we've got x squared plus 5. So none of that's going to be a problem. So we can just say the solutions are and put those in this one here. All right. Number 5 is a little bit different, and we had one of these in another section. If we notice that we have one rational expression equal to another one, we can do that cross multiplying. So let's cross multiply these, and we would have x plus 2 times x minus 7, that's those, equals x plus 5 times x minus 8, and that is those. All right, so then we'll go ahead and FOIL those out. We get x, whoops, back to ink, x squared minus 7x plus 2x, that'd be a minus 5x, minus 14 equals x squared minus 8x plus 5x, that's a minus 3x, minus 40. All right, if I subtract that, add that, and add that, over here everything goes away, and over here I've got negative 2x minus 26 equals 0. And then I'm going to add the 26 over, so I have negative 2x equals 26. Get some room here. And so x equals and this was a positive 26, so that made a negative 26 there, and so I have a positive 13 for my solution. And let's look at our possibilities. Is 13 a problem? It's not a problem in either of the bottom ones, so we can just have A as our solution, and 13 goes in the box. Okay, number 6. Let's look at our LCD issue. Before you do those, usually you want to factor anything that could factor. And so that's the difference of two squares. And I've got x minus 7, x plus 7. All right, and when we pick our LCD, remember we want one of everything and we don't want to repeat. So we go here, yes, we want an x minus 7. And then we need an x plus 7. And we don't need either of these because we already have that. So there's my LCD. So let's move down, get some room, and work this problem. All right, so we had 1 over x minus 7 plus 1 over x plus 7 equals negative 14 over an x squared minus 49. And my LCD was the x plus 7, x minus 7. All right, so here that one goes away, that one goes away. There. That takes care of both of those. All right. So we're left with x plus 7 plus x minus 7 equals negative 14. The 7's cancel out. I've got 2x equals negative 14. X equals negative 7. All right, let's look at the bottom of our expressions. If I have negative 7 and I plug it in for this one, or this one, I'm going to end up with a 0 on the bottom of a fraction, which does not work. So if it doesn't work, then this is a root, but it's extraneous. We solved for it, but when you check it, it doesn't work. So up here, our solution is going to be there are no real solutions, but an extraneous solution of negative 7. Okay. All right, solve the equation and the inequalities. We're just looking at this and we're examining. So where does f of x equal 0? That's going to be the x-intercepts. Okay. All right, so we have these 3 are the x-intercepts, and we can see that's at negative 6 and negative 2 and 2. So that's where it's equal to 0. So we've done that one. Now where is it greater than 0? That means above the x-axis. So we got that piece and we've got that piece. And we want to remember that we always have infinity over here and negative infinity over here. So this yellow piece is from what? Negative 6 to negative 2. And we have this piece, which is from 2 to infinity. All right. Where is it less than 0? Well, that's going to be the pieces that are below the x-axis. So we have from negative infinity to negative 6. And this piece, which is from negative 2 to 2. All right. Now, same thing on number 8. Where are the x-intercepts? We have one at negative 4, at 1, and at 5, it looks like. So negative 4, comma 1, comma 5. And then where is it greater than 0? That's a piece that's above, and that's a piece that's above. Where is it below is going to be this piece and this piece. All right, let's see if we can name those intervals. We've got negative infinity here and positive infinity here. So above, we've got negative infinity up to negative 4. And from negative 4 to 1. All right. And where is it less than? That's from 1 to 5. And from 5 to infinity. Okay. All right, 9 and 10, we need to use our calculator and get a picture of these. So we'll bring this over here, and we're going to put in y1, whoops, we're going to have x cubed minus 25x. Zoom 6 so I can get a picture. Okay, and we're talking about greater than or equal to. Let me change this window, and let's make our y max 30 and see what that gets us, just so we can get a little bit better picture. All right, I'm going to go a little higher so that you can see this. Let's make that 50. Okay, I'm going to bring this picture here. All right, and so we need to find, this is greater than or equal, so we're going to have some closed circle here, here, and here for our intervals. And we've got a positive and we've got negative, and we are looking for where is it a greater, so that's these pieces that are above. We just need to find those x-intercepts. So second calc, when you do these, you need to be sure that in y2 you have 0, because we're saying the intersection here. So let's go here, second calc 5, enter 3 times, that'll give us one of them. So that first one is 0 that we think about right here. X equals 0 is that one. All right, let's find second calc 5, and we're going to move. We're coming back up. Oh, there we go. So let's hit enter 3 times, and we have a 5 there. And if we did it again on our calculator, we would get -5 for this one, but we're going to just write that. So you would repeat that process. So now our interval would be from here to here, and because it's greater than or equal and we've got closed circles, we want to have a bracket from -5 to 0 and from 5 to infinity, and infinity always gets a parenthesis. So we would be there, okay? All right, number 10. All right, number 10, you're supposed to solve this symbolically and graphically. Well, we're going to use our calculator anyway. So we're going to go to y equals, and we're going to clear that out, and x to the 4th minus 10x squared plus 9, and graph. Let me do a zoom 6. And let's see if we can tell just by that picture. We know it's not that. We know it's not that. We know it's not that. So it does look like this one, A. And to solve it, we need these pieces that are under here. So we do need those values of those x-intercepts. Second calc 5, 1, 2, 3. So we have a 1 there. So let's see. All right. I'm going to make this a little bit bigger. All right. So we have an x equals 1 right there. Let's find the other ones. Oh, I went to the same thing, sorry. And that one's 3. So we got x equals 3 there, and that's at 1. And if we did the other ones, we would repeat that, and we'd have a -1 and a -3. So for the pieces that are under, we would have, in your answer, we would have -3 to -1 and 1 to 3. Okay? All right, number 11. We've got to do the same thing. We've got to put that in the calculator. We do need to move this over. So we've got 2x to the 4th plus 6x cubed minus 36x squared less than or equal to 0. So we're going to go here and we're going to clear that out. We're going to have 2x to the 4th plus 6x cubed minus 36x squared. And we're going to hit graph. Okay, let's see what that looks like. Let's change our y-min, see if we can actually see that a little bit better. Let's do a -30. I think we're going to go down a lot more. Let's do a -60. I don't know. Let's try it. Almost. But we do know that this, let's try that picture. What we do know is that this is going to do this. And so we've got that and that. And we're talking about below. So we've got this piece and this piece. And so we would need to find these places where it crosses. And if we did that with second calc 5, because I'm just going to save a little time, and this one is 3, and that's at 0, and that's at -6, and you've got a positive infinity and a negative infinity. So for our solutions, where is it below less than or equal to? And since that's a less than or equal to, that's included, so it's actually not going to break there. So what's it going to be? It's going to be from -6 all the way to 3. And that goes in that box. All right. Number 12, solve the rational inequality. All right, remember the first thing we have to do is solve the top. So x is 2, and the bottom All right, so we solved the top, we solved the bottom, and we are going to draw a line. And we're going to put those in. So that would be x equals negative 2/5, and that's going to be x equals 2. We are going to define the intervals. So we have a positive infinity and a negative infinity. This interval is negative infinity to negative 2/5. This one is negative 2/5 to 2. And this one is 2 to infinity. Okay? Then we're going to pick a test point. Oops. And here I would pick negative 1 to the left of there. I would pick 0 because that'd be easy, and I would pick 3. And when you fill those in and you plug this value into both the top and the bottom, you're trying to see what sign you would get, and you should get a negative here, a plus here, and a negative here. I'm going to let you follow through with that, but that's what you would get. Now we're trying to find where is this thing less than 0. Well, less than 0 is negative. So this one is with negative and this one is negative. So there's our two solutions. So up here in the box, you're going to have from negative infinity to negative 2/5 and from 2 to infinity. Okay. All right. Number 13. Same idea. Same idea. We're going to solve the top. So those are easy. We've got x equals 5, x equals negative 3, x equals 7. So that's our solving the top and the bottom. We're going to go down here and we're going to plug in our three numbers that we got. We've got x equals negative 3, x equals 5, x equals 7. We're going to define our intervals, negative infinity and infinity. So this is negative infinity to negative 3, negative 3 to 5, 5 to 7, and 7 to infinity. Pick your test points. Okay, and I would pick negative 4, 0, 6, and 8. And when you plug those in, you plug them in up here for x and see what sign you get over there. And if you do that, you would get negative, plus, negative, plus. And usually they're going to alternate, but they don't always, so you do need to try them. And what are we looking for? We're looking for less than 0, which would be our negative ones. And so there's your solution. And you can see that it's right here. All right. So I think that will get you through 4-7, which is the end of our chapter.